Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Now, I want you to do something for me. Right now, wherever you are, hold up your hand and look at your fingernail. Go ahead, I'll wait. See that tiny width? That's about 1 centimeter. Seems pretty insignificant, right? Well, what I'm about to tell you is going to completely change how you think about that small measurement. Picture this moment. Imagine Earth adding that much, that 1 centimeter, to its diameter every single second. Not every year, not every day, but right now, and now, and now again. In the time it takes you to tie your shoes, our planet grows 30 centimeters wider. During your morning shower, Earth expands by 6 meters. This isn't some distant cosmic event happening in another galaxy. This is our world, beginning a transformation that starts with a whisper and ends with a scream. The ground beneath your feet, stable for 4.5 billion years, suddenly enters an unstoppable growth spurt that will rewrite every rule of existence. And here's the crazy part. You probably wouldn't even notice it at first. Think about that for a second. 1 centimeter per second doesn't sound like much when you say it out loud, but numbers can be deceiving, can't they? Let me walk you through what this really means, because once you understand the scale of what we're talking about, you'll never look at our planet the same way again. In just 1 minute, Earth grows 60 centimeters wider. That's about 2 feet. Still doesn't sound too scary, does it? But keep going. In 1 hour, our planet has expanded by 36 meters. That's about the length of a basketball court added to Earth's diameter. In 24 hours, 864 meters. That's more than half a mile of new Earth, appearing from, well, that's one of the terrifying questions we'll explore. But here's where it gets really wild. This isn't linear growth we're dealing with. This is exponential expansion of everything. The surface area, the volume, the very fabric of our world stretching like bread dough in an oven. Except, instead of 30 minutes of baking, we're talking about a process that, once started, never stops. Now, I know what you're thinking. How is that even possible? Where would all this new Earth come from? And you're absolutely right to ask that question, because it leads us straight into one of the most mind-bending physics problems you can imagine. See, there are really only 2 ways this could happen, and both of them are absolutely terrifying. Either Earth is somehow gaining mass, matter literally materializing from nothing, or it's expanding without adding mass, like a balloon being inflated. Both scenarios lead to complete and utter catastrophe, just different flavors of apocalypse. Let's start with the first possibility. If Earth is actually gaining mass, we're talking about 1.4 million cubic meters of new material appearing every single second. Imagine the Empire State Building materializing from nothing every 4 hours. That's the scale we're dealing with. Where does this matter come from? Maybe it's spontaneous quantum materialization at spreading zones, or perhaps dark matter suddenly deciding to join our party. The energy requirement alone should tell you how impossible this is. More power than our sun produces in an entire year, compressed into each day of growth. But here's what's really unsettling about the mass gain scenario. If Earth keeps getting heavier, our gravity gets stronger. Not by much at first, maybe 0.02% after a week. You wouldn't feel it. But sensitive instruments would detect something else entirely. We'd be falling toward the sun. You see, orbital mechanics is a delicate dance. Earth stays in its perfect orbit because of a precise balance between the sun's gravity pulling us in and our orbital velocity carrying us forward. Add mass to Earth, and that balance shifts. Our orbit decays. We spiral inward, slowly at first, then faster and faster. The blue marble that's been our home for billions of years becomes a cosmic wrecking ball, destined to crash into the very star that gave us life. Now let's consider the other possibility: expansion without mass gain. This might sound less scary at first, but trust me, it's not. If Earth expands like a balloon but keeps the same mass, our density drops. And when density drops, gravity weakens. Every single second, the force holding you to the ground gets a little bit weaker. Picture this: you're standing in your backyard, and the ground beneath your feet is literally pulling apart. The soil cracks. Your house, built on a foundation designed for a planet of very specific dimensions, suddenly finds itself on a world that's growing beneath it. The basement walls bow outward. The concrete driveway develops stress fractures that spread like spider webs. But here's the really terrifying part about the density loss scenario. As gravity weakens, Earth loses its ability to hold onto its atmosphere. The air you're breathing right now, the protective blanket that shields us from space radiation and keeps our planet's temperature stable, begins to drift away into the void. It starts slowly. The outermost layers of atmosphere simply leave. They escape Earth's gravitational well like balloons released from a child's hand. But as our planet continues to expand and gravity continues to weaken, the process accelerates. The stratosphere goes first, taking our ozone layer with it, then the upper atmosphere. Eventually, even the air at sea level begins to thin. Every breath becomes more difficult. Your morning jog leaves you gasping. Airlines ground their fleets because there isn't enough air density for wings to generate lift. And all the while, the ground keeps pulling apart beneath your feet, creating vast chasms where once there were solid foundations. Now, you might be wondering about the timescale here. How long would it take for things to get really bad? Well, here's where the mathematics become both fascinating and horrifying. At 1 centimeter per second, Earth doubles in size every 142 years. That might sound like a long time, but think about the implications. Within 500 years, our planet would be larger than Jupiter. But long before we reach that point, fundamental transitions occur that make the word catastrophic seem inadequate. When Earth reaches just twice its current size, something that happens in less than 3 centuries at this rate, the Moon faces a crisis. Our faithful companion, locked in its ancient orbital dance, suddenly finds itself circling a planet that's grown too large for their relationship to remain stable. The Moon's orbit decays. It spirals inward, getting closer and closer to a world that's expanding to meet it. The collision, when it comes, liquefies both bodies. 4.5 billion years of Earth's history, every mountain range, every ocean, every trace of life that ever existed, gets incorporated into a molten ball of rock and metal. The blue marble becomes a hellish sphere of lava, spinning through space where our solar system used to have 2 distinct celestial bodies. But wait, it gets worse. If mass is being added proportionally as Earth expands, another threshold looms on the horizon. At roughly Jupiter's mass, something incredible and terrible happens. Electron degeneracy pressure in our core triggers nuclear fusion. Earth ignites, becoming a small star. Think about that for a moment. Our blue marble, the pale blue dot that Carl Sagan wrote so beautifully about, transforms into a red dwarf star. The gentle yellow sun that has warmed our world for billions of years suddenly has company, a second star, born from the corpse of Earth itself, sterilizing the inner solar system with radiation. Every planet closer to the sun than Mars gets cooked. Venus, already a hellscape, becomes something even more extreme. Mercury simply vaporizes. And Earth? Earth becomes something so fundamentally different that calling it Earth at all seems almost insulting to the memory of what it once was. Without mass addition, we face a different but equally devastating fate. Earth becomes a gossamer sphere, its gravity too weak to hold atmosphere or water. We end up with a giant rocky bubble drifting through space, a hollow mockery of a planet, like a soap bubble blown by a cosmic child, beautiful from a distance, but containing nothing but vacuum and the fading echoes of what used to be a living world. Either path erases every trace of the world we knew, every city ever built, every mountain ever climbed, every ocean ever sailed, every song ever sung, all of it gone, transformed into something unrecognizable. And here's what really gets me about this thought experiment. It forces you to confront just how perfectly balanced our world actually is. Earth's size isn't just some random number that happened to work out. It's the foundation of absolutely everything. The stability of our planet's diameter over billions of years isn't luck. It's what makes life possible. Change our size by even 1% over geological time, and plate tectonics fails. No plate tectonics means no carbon cycle. No carbon cycle means no climate regulation. The magnetic field that protects us from deadly solar wind, it's generated by precise convection patterns in our liquid iron core, patterns that depend on exact pressure from exact mass at exact size. Every earthquake that reshapes our landscape, every volcano that adds new land to our continents, every raindrop that nourishes our forests, all of it exists because Earth stopped growing 4.5 billion years ago and has remained the same size ever since. This thought experiment reveals something profound about our planet. Earth isn't just a big rock floating through space. It's more like a living organism, countless systems in perfect balance, each depending on all the others. Disturb one parameter, even slowly, and the whole system collapses faster than dominoes falling in sequence. Our mundane, unchanging Earth, the world we take for granted every single day, suddenly seems like the most precisely tuned machine in the universe. And you know what? It is. The next time you're outside, take a moment to feel the solid ground beneath your feet. Notice how the air fills your lungs effortlessly. Watch how the clouds drift across a sky that's been exactly the same distance above your head for your entire life and for countless generations before you. All of this stability, all of this perfect balance, exists because our planet's size was locked in place billions of years ago by the fundamental laws of physics. Change that one simple parameter, add just 1 centimeter per second to Earth's growth rate, and everything we know and love disappears into cosmic horror. But here's the beautiful thing. Earth isn't growing. It's been the same size for longer than you can possibly imagine, and as long as the laws of physics continue to work the way they always have, it will stay that size for billions of years to come. Our stable, predictable, wonderfully boring planet will keep spinning through space at exactly the right distance from the sun, with exactly the right gravity to hold our atmosphere, and exactly the right size to keep all the geological systems running that make our world a place where life can thrive. That fingernail width we started with, that insignificant little centimeter, it turns out to be the perfect measurement for understanding just how precious our stable Earth really is. So now that we've wrapped our heads around what 1 centimeter per second actually means, let's dive into the real mystery here. And trust me, this is where things get absolutely wild. 4 billion years ago, cosmic debris coalesced into the Earth we know today. Picture it. Countless asteroids, comets, and chunks of space rock slowly gathering together under the relentless pull of gravity, building up layer by layer until they formed a precise sphere of rock and metal. Once that process finished, Earth's size got locked in place by physics itself. The planet we're standing on right now is essentially the same size it was when the first primitive life forms started stirring in ancient oceans. But now, in our thought experiment, something unprecedented begins. The most fundamental question of all emerges. Where does the new Earth come from? I mean, seriously, think about this for a second. If we're adding mass to our planet every single second, The universe must be robbing matter from somewhere. You can't just create matter from nothing, right? That would violate some pretty basic laws of physics. So where is it coming from? One possibility that makes my brain hurt just thinking about it. Spontaneous quantum materialization at spreading zones. Imagine if the quantum vacuum, that supposedly empty space between atoms, suddenly decided to start coughing up new matter. Scientists know that even empty space isn't really empty. It's full of virtual particles popping in and out of existence all the time. But what if something triggered these virtual particles to become real, permanent matter? What if they started materializing faster than they disappeared? Picture this happening along every fault line, every tectonic plate boundary, every place where Earth's crust meets and spreads. New rock, new metal, new everything just appearing from the quantum foam like cosmic magic. The mathematics alone should tell you how impossible this is. We're talking about energy requirements that dwarf anything we can imagine. Or maybe it's dark matter suddenly deciding to join our party. You know, that mysterious stuff that supposedly makes up most of the universe but doesn't interact with ordinary matter. What if something changed? Some cosmic switch got flipped, and dark matter started converting itself into regular matter right here on Earth. Every second, invisible dark matter particles rushing toward our planet and transforming into solid rock and molten metal. Here's what really gets me about this scenario. Each second, 1.4 million cubic meters of new material would need to appear. Let me put that in perspective for you. The Empire State Building has a volume of about 370,000 cubic meters. So we're talking about the equivalent of almost 4 Empire State Buildings worth of new matter materializing every single second. Every 4 hours, enough new Earth to rebuild Manhattan from scratch. And here's the energy requirement that should make your head spin. More power than our sun produces in an entire year, compressed into each day of growth. Where does that energy come from? What kind of cosmic battery could power a process like that? We're not just talking about rearranging existing matter, we're talking about creating new matter from nothing, and that requires energy on a scale that makes nuclear weapons look like birthday candles. But wait, there's something even more unsettling about the mass gain scenario that I haven't told you yet. If Earth keeps getting heavier, our gravity gets stronger. Now, 0.02% doesn't sound like much after a week, and honestly, you wouldn't feel it. Your coffee would still pour the same way, your dog would still chase tennis balls with the same enthusiasm. But sensitive instruments, they detect something else entirely. You see, we'd be falling toward the sun. Let me explain what I mean by that, because this is where orbital mechanics gets really scary. Earth stays in its perfect orbit because of a delicate balance. The sun's gravity is constantly trying to pull us inward, but our orbital velocity carries us forward fast enough that we keep missing the sun, so to speak. We're essentially in permanent free fall around our star, moving sideways fast enough that the ground keeps curving away beneath us. Add mass to Earth, and that balance shifts. Our orbit decays. We spiral inward, slowly at first, then faster and faster. The blue marble that's been our home for billions of years becomes a cosmic wrecking ball destined to crash into the very star that gave us life. Now, you might think this would take millions of years, and maybe we'd have time to figure something out. But here's the thing about orbital decay. It's not linear. It's exponential. Once you start falling toward the sun, the process accelerates. You fall faster, which makes you fall even faster, which makes you fall faster still. Before you know it, Earth is screaming through space on a collision course with a ball of nuclear fire. But let's consider the other possibility, because honestly, it's not any better. What if Earth expands like a balloon but keeps the same mass? This might sound less scary at first, but trust me, it's not. If Earth expands without gaining mass, our density drops. And when density drops, gravity weakens. Every single second, the force holding you to the ground gets a little bit weaker. Now, this creates a completely different kind of nightmare. Picture this. You're standing in your backyard, and the ground beneath your feet is literally pulling apart. At first, it's just tiny cracks in the soil. Your driveway develops stress fractures that spread like spider webs. But as the expansion continues, those cracks become chasms. Your house, built on a foundation designed for a planet of very specific dimensions, suddenly finds itself on a world that's growing beneath it. The basement walls bow outward under the stress. The wooden frame creaks and groans as the very ground it sits on stretches like taffy. Every building, every bridge, every structure humanity has ever built faces forces it was never designed to. But here's what's really terrifying about the density loss scenario. As gravity weakens, Earth loses its ability to hold onto its atmosphere. The air you're breathing right now, that protective blanket that shields us from space radiation and keeps our planet's temperature stable, begins to drift away into the void. It starts with the outermost layers. The exosphere, that thin boundary between Earth's atmosphere and space, simply disappears. Then the thermosphere goes, taking with it our protection from solar X-rays and ultraviolet radiation. The mesosphere follows, and with it goes our shield against most meteoroids. But the process doesn't stop there. As Earth continues to expand and gravity continues to weaken, the atmospheric loss accelerates. The stratosphere goes next, taking our precious ozone layer with it. Without ozone to filter the sun's radiation, the surface of Earth becomes a hostile environment where stepping outside without protection means instant sunburn and long-term cancer risk. Eventually, even the air at sea level begins to thin. Every breath becomes more difficult. Your morning jog leaves you gasping like you're climbing Mount Everest. Airlines ground their fleets because there isn't enough air density for wings to generate lift. Commercial aviation becomes impossible first, then private flights, then eventually even helicopters can't stay airborne, and all the while, the ground keeps pulling apart beneath your feet. Imagine trying to walk across a surface that's constantly stretching. Every step you take, the distance to your destination increases. Roads crack and separate. Railroad tracks bend and warp as the ties spread apart. Pipelines burst as the expanding ground tears them in half. Now, here's where the mathematics become both fascinating and horrifying. At 1 centimeter per second, Earth doubles in size every 142 years. That might sound like a long time when you're thinking about human lifespans, but in geological terms, it's the blink of an eye. Think about what this means for the timeline of catastrophe. Within just 500 years, our planet would be larger than Jupiter, but we don't have to wait 500 years for things to get really bad. Major transitions start happening much, much sooner. When Earth reaches just twice its current size, in point 1, something that happens in less than 3 centuries, the Moon faces an existential crisis. Our faithful companion, locked in its ancient orbital dance for billions of years, suddenly finds itself circling a planet that's grown too large for their relationship to remain stable. You see, the Moon's orbit depends on a delicate balance between Earth's gravity, pulling it inward, and its orbital velocity carrying it forward. Change Earth's size dramatically, and that balance gets disrupted. If we're gaining mass, Earth's stronger gravity starts reeling the Moon in like a fish on a line. If we're losing density, our weaker gravity can't hold the Moon in its current orbit, and it begins to drift away. In the mass gain scenario, the Moon spirals inward, getting closer and closer to a world that's expanding to meet it. The collision, when it comes, is absolutely catastrophic. 4.5 billion years of Earth's history, every mountain range that ever rose from the sea, every ocean that ever teemed with life, every trace of civilization that ever existed, gets incorporated into a molten ball of rock and metal. The blue marble becomes a hellish sphere of lava, spinning through space where our solar system used to have two distinct celestial bodies. The tides that shaped our coastlines, the gentle tug that stabilized our planet's rotation, the romantic presence that inspired countless poems and songs, ABZ. All of it ends in a cosmic collision that would make the asteroid impact that killed the dinosaurs look like a gentle tap. But if mass is being added proportionally as Earth expands, there's another threshold lurking in. Our future that's even more mind-bending. At roughly Jupiter's mass, something incredible and terrible happens deep in our planet's core. The pressure from all that new material triggers electron degeneracy pressure, and nuclear fusion begins. Earth ignites, becoming a small star. Let that sink in for a moment. Our blue marble, the pale blue dot that Carl Sagan wrote so beautifully about, transforms into a red dwarf star. The gentle yellow sun that has warmed our world for billions of years suddenly has company, a second star, born from the corpse of Earth itself. Picture our solar system with two stars instead of one. The delicate gravitational dance that keeps all the planets in their orbits gets completely disrupted. The inner solar system becomes a hellscape of radiation and gravitational chaos. Venus, already hot enough to melt lead, becomes something even more extreme. Mercury simply vaporizes, its atoms scattered into space by the radiation pressure from Earth's new stellar incarnation. Mars might survive, barely, but its thin atmosphere would be stripped away entirely. The asteroid belt would be disrupted, sending chunks of rock careening in all directions. Even Jupiter might find its orbit altered by the presence of a second star in the inner solar system. And Earth? The living, breathing world that nurtured billions of years of evolution, becomes something so fundamentally different that calling it Earth at all seems almost insulting to the memory of what it once was. Every forest that ever grew, every river that ever flowed, every creature that ever lived gets transformed into the nuclear fires of stellar fusion. Now, in the density loss scenario, we face a different but equally devastating fate. As Earth expands without gaining mass, it becomes less and less like a planet, and more like a cosmic bubble. Our gravity becomes too weak to hold onto our atmosphere, too weak to maintain our molten core, too weak to keep our geological systems running. We end up with a giant rocky sphere, hollow and lifeless, drifting through space like a ghost of what used to be a living world. Imagine the Earth as a soap bubble blown by a cosmic child, beautiful from a distance, iridescent in the starlight, but containing nothing but vacuum and the fading echoes of what used to be a thriving biosphere. Either path leads to the complete erasure of everything we know and love. Every city ever built, every mountain ever climbed, every ocean ever sailed, every song ever sung, every story ever told, any one, all of it gone, transformed into something unrecognizable. And here's what really haunts me about this thought experiment. It forces you to confront just how perfectly balanced our world actually is. Earth's size isn't just some random number that happened to work out okay. It's the foundation that makes everything else possible. The stability of our planet's diameter over billions of years isn't some cosmic accident. It's what allows plate tectonics to function, moving continents around, and recycling carbon between the atmosphere and the Earth's interior. It's what maintains the right pressure in our core to keep the magnetic field running, protecting us from solar wind and cosmic radiation. It's what keeps our gravity at exactly the right strength to hold our atmosphere, but not crush us under our own weight. This impossible machine we call Earth only works because every component is precisely calibrated. Change one parameter, even slowly, and the whole system collapses like a house of cards in a hurricane. But here's the beautiful thing that this nightmare scenario helps us appreciate. Earth isn't growing. It stopped growing 4.5 billion years ago, and it's been exactly the same size ever since. This cosmic machine keeps running, day after day, year after year, eon after eon, maintaining the perfect conditions that allow life to flourish. The next time you step outside, remember that you're standing on the surface of an impossible machine, a planet-sized engine that's been running flawlessly for longer than you can possibly imagine, and it will keep running, maintaining that perfect balance for billions of years to come. All right, so we've talked about the big picture, the cosmic implications, the mind-bending physics of it all. But now, I want to bring this down to a human scale. I want you to imagine what it would actually feel like to live through the first day of Earth's expansion. Because here's the thing, you probably wouldn't even notice it at first. Dawn breaks on expansion day, though most people don't realize anything unusual is happening. The sun rises just like it has for billions of mornings before. You make your coffee, check your phone, maybe scroll through the news. Everything seems perfectly normal. But deep underground, in monitoring stations scattered across the globe, seismologists are starting to see something strange. Not earthquakes exactly, but continuous low-level tremors everywhere simultaneously. It's like the entire planet has developed a barely perceptible vibration, a cosmic hum that shouldn't exist. Dr. Sarah Chen is working the night shift at the United States Geological Survey when she first notices it. She's been monitoring seismic activity for 15 years, and she's never seen anything like this. The readouts from stations in California show tremors. So do the ones in Japan, and Alaska, and Chile, and every other monitoring station on the planet. At first she thinks it's equipment failure, maybe a software glitch affecting the global network. But as she runs diagnostics, everything checks out. The instruments are working perfectly. They're all detecting the same thing, a subtle but persistent shaking that seems to be coming from everywhere at once. By mid-morning, GPS systems worldwide start reporting impossible errors. Your smartphone thinks you're 30 meters from where you actually are. Navigation apps show you floating in the middle of a lake when you're clearly standing on dry land. Delivery drivers find themselves completely lost in neighborhoods they've worked for years. The first person to realize what's happening is a construction foreman named Mike Rodriguez in Phoenix, Arizona. He's been building houses for 23 years, and he's got an eye for precision that comes from decades of measuring twice and cutting once. When he arrives at the job site Tuesday morning, something's off. The foundation they poured yesterday doesn't match the blueprints anymore. Not by much. Just a few centimeters, but Mike notices. The corners aren't quite square, the measurements don't add up. He checks his instruments, rereads the plans, even calls his surveyor to come back out. Everything should be perfect, but somehow, overnight, the ground itself seems to have shifted. It's like the earth grew while we weren't looking, he tells his crew, not realizing how literally true that statement is. Meanwhile, in laboratories around the world, physicists are scratching their heads over gravitometer readings. These incredibly sensitive instruments measure tiny changes in Earth's gravitational field, and they're all showing the same impossible result. Gravity is getting stronger. Not by much, but by an amount that should be completely impossible over such a short time frame. Then comes the first crack. It happens at 11:47 a.m. Pacific Time, somewhere in the Pacific Ocean about 800 miles west of San Francisco. The seafloor splits with a sound like thunder that travels through the ocean, picked up by underwater microphones thousands of miles away. But this isn't a normal earthquake. Normal earthquakes last seconds or minutes. This crack keeps growing, spreading like a zipper opening along the ocean floor. Marine biologists monitoring deep-sea cameras suddenly see something unprecedented. Molten rock fountaining from a rift that wasn't there yesterday. The Mid-Atlantic Ridge, the Pacific Ring of Fire, every major fault line on the planet simultaneously comes alive with volcanic activity. By noon, seismologists have a name for what they're seeing. Global, synchronous, spreading. Every tectonic plate boundary has become active at once. The Ring of Fire, that horseshoe of volcanoes and fault lines around the Pacific Ocean, lives up to its name as molten rock fountains from spreading rifts all around its perimeter. Doctor, Yuki Tanaka is monitoring the Japan Meteorological Agency's seismic network when the alerts start pouring in. Mount Fuji, dormant for 3 centuries, shows signs of awakening. So does every other volcano in Japan. And not just Japan, reports are flooding in from Indonesia, the Philippines, Chile, Alaska, Italy. Volcanoes that have been quiet for decades are suddenly stirring to life. "This isn't possible," she murmurs, staring at her screens. "You can't have global volcanic activity without a trigger. Where's the trigger?" The answer, of course, is that the trigger is the planet itself, growing beneath their feet at 1 centimeter per second. But nobody's figured that out yet. All they know is that the Earth is behaving in ways that defy every model, every prediction, every understanding of how geology is supposed to work. By early afternoon, the effects start becoming visible to ordinary people. In Tokyo, subway tunnels begin to show stress fractures. The perfectly engineered concrete that was supposed to last for centuries starts developing spiderweb cracks as the ground itself shifts and stretches beneath the city. In Los Angeles, the San Andreas Fault becomes something more than just a fault line. It starts opening up, creating a visible crack in the ground that grows wider by the hour. What was once a barely perceptible boundary between tectonic plates becomes a canyon that you could fall into. Office workers in downtown LA look out their windows and see the streets developing cracks. Not potholes, not normal wear and tear, but systematic fractures that radiate outward from fault lines like broken glass. The carefully laid asphalt and concrete that forms the foundation of modern civilization begins to pull apart under stresses it was never designed to handle. Buildings designed to withstand earthquakes face something entirely new, the ground pulling apart beneath them. Earthquake-resistant construction is based on the idea that the ground will shake, not that it will stretch like taffy. Steel beams groan under expansion, stress that exceeds all safety margins. Concrete foundations crack as the very earth they're anchored to grows larger. The Transamerica Pyramid in San Francisco, that iconic pointed skyscraper built to flex with earthquake motion, starts developing stress fractures as its foundation expands. The building's flexible design, which allows it to sway during tremors, can't accommodate the ground itself stretching beneath it. By late afternoon, civil engineers are in emergency meetings trying to figure out what's happening. Bridge inspectors report expansion joints that have stretched beyond their limits. Highway overpasses show stress cracks. The infrastructure that connects our cities, built to accommodate normal thermal expansion and earthquake motion, begins failing under forces no one anticipated. In San Francisco, the Golden Gate Bridge shows its first signs of stress. The massive cables that support the roadway, engineered to handle wind and traffic loads, start exhibiting unusual tension as the towers supporting them spread slightly further apart. It's only a few centimeters, but in a structure where every measurement is critical, a few centimeters might as well be a mile. As evening approaches, news networks struggle to make sense of the day's events. Geologists appear on television trying to explain global volcanic activity and seismic anomalies, but their explanations don't add up. How do you have worldwide geological activity without a cause? How do you have GPS errors across the entire planet? How do you have buildings showing expansion stress when the temperature hasn't changed? Dr. Elena Vasquez, the geophysicist at Caltech, finds herself on CNN trying to explain the inexplicable. What we're seeing today defies our current understanding of plate tectonics, she says, her voice betraying the strain of trying to sound calm while discussing something that should be impossible. Global synchronous activity like this would require a trigger of unprecedented magnitude. We simply don't know what could cause the entire planet's geological systems to activate simultaneously. The interviewer presses her. Could this be related to climate change? Solar activity? Some kind of cosmic event? Honestly, Dr. Vasquez replies, nothing in our models predicts this. We're dealing with something completely outside our experience. As the sun sets on expansion day, emergency management agencies worldwide are trying to assess the damage. Thousands of buildings show stress fractures. Transportation networks are disrupted as roads crack and rail lines warp. Airports ground flights as runways develop fissures that make landing dangerous. But the most unsettling thing is that nobody can explain why it's happening. Every expert, every model, every theory comes up short. The Earth is behaving like a machine that suddenly started operating outside its specifications, and no one can find the manual. 24 hours in, Earth has grown 864 meters wider. That's almost half a mile of new planet, and civilization's foundations are literally cracking apart under the strain. In hospital emergency rooms, doctors see an uptick in anxiety-related visits. People feeling dizzy, disoriented, like something fundamental has shifted in their world. And in a sense, it has. The very ground beneath their feet, stable for their entire lives, has become unreliable. Children notice it first, the way children often do. 7-year-old Emma Martinez in Phoenix tells her mother that her bedroom feels bigger. The walls are further apart, Mummy. Her mother dismisses it as imagination, but Emma's right. The house has stretched, just barely, just enough for a child's keen perception to notice what adults rationalize away. By midnight, seismic monitoring stations have recorded over 10,000 separate events. Not 10,000 earthquakes, 10,000 instances of the ground moving in ways that don't fit any existing classification. The planet has essentially been shrugging all day, a slow-motion convulsion that's rewriting the rules of geology in real time. Emergency planners work through the night, trying to develop response protocols for a disaster they don't understand. How do you prepare for global geological instability when you don't know what's causing it? How do you evacuate people when there's nowhere to evacuate to that isn't equally affected? The International Space Station provides the only perspective that makes sense of what's happening. Astronauts looking down at Earth notice something that ground-based observers can't see. The planet looks different. Not dramatically, not in any way that shows up in photographs, but to eyes that have seen Earth from space hundreds of times, there's something subtly wrong with its proportions. Commander Lisa Park has been in space for 4 months, long enough to develop an intimate familiarity with Earth's appearance from orbit. It's probably just my imagination. She radios to Mission Control, but the planet looks rounder somehow, like someone inflated it just a tiny bit. Mission Control dismisses her observation. Optical illusions are common in space, and the human eye isn't precise enough to detect the kind of small changes she's describing. But Lisa Park isn't imagining things. From her vantage point 250 miles above the surface, she's witnessing something that will take ground-based observers weeks to fully understand. As the first day of expansion comes to an end, the world's leading scientists gather in emergency conferences, trying to piece together a puzzle with pieces that don't seem to fit any known pattern. Geologists talk to physicists, who talk to astronomers, who talk to climatologists. Nobody has answers, but everybody agrees on one thing. Whatever's happening to Earth is just getting started. The expansion that began as an imperceptible tremor has become a global crisis, and tomorrow it will be worse, and the day after that, worse still. Because this isn't a one-time event or a temporary anomaly, this is the beginning of a transformation that will remake everything we know about our world. 864 meters might not sound like much in the context of a planet 12,756 kilometers in diameter, but it's enough to crack foundations, disrupt navigation systems, and leave the world's brightest minds scrambling for explanations that don't exist. Day 1 of Earth's expansion ends not with answers, but with the dawning realization that something fundamental has changed. The stable, predictable world we've always known has become unstable and unpredictable. And somewhere in the back of everyone's mind is the terrifying question: if this is what one day looks like, What will a week bring? So, we've made it through the first day, and things are already looking pretty chaotic. But here's the thing about exponential processes. They don't stay manageable for long. What seemed like isolated incidents on day 1 becomes a global catastrophe by day 7. Let me walk you through what week 1 of Earth's expansion looks like, because it's when the world truly starts to understand that everything has changed. 7 days of relentless growth transform Earth into something alien, something that no human has ever seen before. The planet that supported billions of years of life becomes a world where the very concept of solid ground loses all meaning. By day 3, the Himalayas have risen an additional 100 meters. Now, I know what you're thinking. Mountains grow all the time, right? That's how geology works. But this isn't the slow, steady uplift that happens over millions of years. This is happening fast enough to watch. Dr. Pemba Sherpa has been guiding climbers up Everest for 15 years. He knows every rock formation, every ridge, every landmark on the world's tallest mountain. When he looks up at the peak on Wednesday morning, something's wrong. The summit looks higher, not by a lot, but enough that he can tell. The snow plume blowing off the top is at a different angle against the sky. The mountain is growing, he tells his expedition team. And for once, he's not speaking metaphorically. The additional height isn't just happening at the summit. The entire Himalayan range is being pushed upward by the expanding crust beneath. But here's where it gets really dangerous. Mountains have something called an angle of repose, the steepest angle at which loose material can pile up before it starts sliding down. When you push mountains higher faster than they can adjust, you exceed that critical angle. Avalanches cascade continuously down slopes that have become too steep to hold their snow and rock. The sound of falling ice and stone echoes through valleys that have been stable for centuries. Base camps get evacuated as entire cliff faces let go, sending millions of tons of debris thundering into valleys below. But the Himalayas aren't the only mountains experiencing this crisis. The Andes, the Rockies, the Alps, every major mountain range on Earth faces the same problem. They're being pushed higher by an expanding crust, and they're shedding material like giant stone trees losing their leaves in a cosmic windstorm. Meanwhile, something even more dramatic is happening to the world's oceans. The Mediterranean Sea, its basin stretching as the seafloor expands, drops by 20 meters in the first week. 20 meters! That's like a 6-story building worth of water suddenly having more space to spread out. Coastal cities around the Mediterranean wake up to find their harbours dry. Venice, that floating jewel of architecture, finds itself sitting on mudflats. The gondolas that have navigated its canals for centuries lie stranded in channels that no longer exist. Street Marx Square, which has been dealing with regular flooding for years, suddenly finds itself well above sea level. In Barcelona, the famous beaches have expanded outward by hundreds of meters as the receding sea exposes seafloor that hasn't seen sunlight in millions of years. Marine archaeologists make incredible discoveries as ancient shipwrecks emerge from depths that are no longer deep, but there's no time to study them properly because everything is changing too fast. The Atlantic and Pacific Oceans face the same phenomenon. As the ocean basins expand, water that was once confined to relatively small areas spreads out over vast new territories. Sea levels drop globally, not because there's less water, but because there's more space for that water to occupy. Rivers, those ancient highways of human civilization, find themselves in complete chaos. The Amazon, which has flowed in essentially the same direction for millions of years, reverses course in some stretches as the expanding ground changes its gradient. What was once a gentle slope toward the Atlantic becomes a confusing landscape where water doesn't know which way to flow. The Mississippi River, that great artery of American commerce, develops multiple new channels as its banks stretch apart. Barge traffic comes to a standstill as captains find themselves navigating waterways that change configuration daily. The port of New Orleans, built at the river's mouth to take advantage of its flow into the Gulf of Mexico, finds itself stranded as the river carves new paths to the sea. But it's what happens to the weather that really drives home how interconnected our planet's systems are. The jet stream, that great atmospheric river that drives weather patterns across the northern hemisphere, begins to fragment into chaotic swirls as Earth's rotation slows. You see, our planet's rotation rate depends on its moment of inertia, 1z, basically, how its mass is distributed. As Earth expands, that distribution changes. It's like a figure skater extending their arms during a spin. The skater slows down, and so does our planet. A day now lasts 24 hours and 8 minutes. That might not sound like much, but it's enough to completely disrupt atmospheric circulation patterns that have been stable for millions of years. Weather systems that used to move predictably from west to east now stall and spiral in place. Hurricane-force winds appear in areas that have never seen them before. Deserts experience flash floods, while rainforests endure unprecedented droughts. Dr. Maria Santos, a climatologist at the University of São Paulo, watches her computer models fail one after another. Everything we know about atmospheric dynamics assumes a planet of constant size and rotation rate, she explains to her increasingly panicked research team. Change those parameters, and the whole system becomes unpredictable. Temperature regulation, which depends on consistent air circulation patterns, breaks down entirely. The Amazon rainforest, that great green lung of our planet, experiences temperatures 50 degrees above normal as air circulation fails to bring cooling moisture from the Atlantic. Massive sections of rainforest simply combust in the unprecedented heat. Meanwhile, Siberia experiences blizzards in July as disrupted jet stream patterns drag Arctic air thousands of miles south. The growing season that feeds much of the world's population becomes impossible to predict as weather patterns that evolved over millions of years collapse in a matter of days. Migratory birds provide some of the most heartbreaking evidence of how thoroughly Earth's expansion disrupts natural systems. Species that have followed the same routes for thousands of generations find themselves completely lost. Their magnetic navigation systems, evolved to work with Earth's specific magnetic field configuration, become useless as the planet's internal dynamics change. Flocks of Arctic terns, those incredible birds that fly from Arctic to Antarctic and back each year, circle endlessly over landscapes they no longer recognize. The magnetic landmarks they've relied on for navigation have shifted or disappeared entirely. Millions of birds exhaust themselves flying in random directions, searching for routes home that no longer exist. If Earth is gaining mass during this expansion, gravity has increased by 2% after a week. That might not sound like much, but it's enough to have profound effects on anything larger than insects. A person who weighs 70 kilograms on Monday weighs 71.4 kilograms on Sunday. Your morning jog becomes noticeably more difficult. Elderly people struggle with mobility as their effective weight increases, but it's large animals that suffer the most. Elephants, giraffes, whales, creatures whose body structures evolved for Earth's specific gravitational field, find themselves unable to support their own weight. Elephant herds in Africa collapse as animals that have roamed the savanna for millions of years can no longer lift their massive bodies against the strengthening pull of gravity. Whales fare even worse. These magnificent creatures, the largest animals ever to exist on Earth, depend on water's buoyancy to support their enormous size. As gravity increases, even the ocean can't provide enough support. Mass strandings occur worldwide as whales become too heavy for their own circulatory systems to function properly. Trees, those ancient sentinels that have stood for centuries, begin to topple as their weight exceeds what their root systems and structural wood can support. Redwood forests in California, giant sequoias that have survived ice ages and droughts, fall like dominoes as Earth's changing gravity overwhelms structures that were perfectly balanced for the old world. But perhaps the most psychologically devastating effect is what happens to human structures. Every building, every bridge, every monument that represents human achievement begins to show signs of stress that no engineer anticipated. The Eiffel Tower, that iron lattice masterpiece that has defined Paris's skyline for over a century, develops stress fractures as its base spreads slightly apart. The careful engineering that allowed it to sway gracefully in the wind can't accommodate the ground itself stretching beneath its foundation. The Great Wall of China, that ancient wonder that has stood for over 2,000 years, begins to crack and separate as the mountainous terrain it follows changes shape. Sections that have withstood earthquakes, invasions, and centuries of weather start to crumble as the very mountains they're built on grow taller and steeper. Skyscrapers in New York City show their first signs of structural failure. The Empire State Building, the Chrysler Building, One World Trade Center, these monuments to human engineering prowess develop stress fractures as their foundations expand. The bedrock of Manhattan, that solid schist that has supported the city's vertical ambitions, begins to shift and stretch. By day 5, civil engineers worldwide issue unprecedented warnings. No structure built before the expansion began can be considered safe. The fundamental assumptions that underlie all construction, that the ground is stable, that gravity is constant, that the earth doesn't change size, have all been violated. Emergency evacuation orders go out for major cities, not because of any immediate threat, but because nobody can predict which buildings will fail first as the expansion continues. Manhattan begins to empty as millions of people flee a city where every skyscraper has become a potential death trap. The psychological impact is almost as devastating as the physical effects. Humans are creatures of habit, of routine, of predictability. We build our lives around the assumption that certain things will always be the same. The sun will rise in the east. Gravity will pull things downward. The ground will stay where we left it. But now, all of those assumptions are wrong. Children wake up screaming from nightmares about falling upward. Adults develop agoraphobia, afraid to leave their homes because the very concept of solid ground has become meaningless. Psychiatric hospitals report 1,000% increase in anxiety-related admissions. Dr. Jennifer Walsh, a psychologist in Seattle, finds herself treating patients for a condition that has no name, the psychological trauma of living on a planet that has become unreliable. Humans need stability to function, she explains. When the most basic assumption, that the Earth is solid and unchanging, gets violated, it can trigger existential panic that's almost impossible to treat. By the end of week 1, humanity faces a crisis unlike anything in recorded history. Not a war, not a pandemic, not a natural disaster, but something far more fundamental. The failure of reality itself to behave according to the rules that have governed existence for billions of years. Scientists work around the clock trying to understand what's happening, but their instruments and models are all based on assumptions that no longer apply. How do you study a planet that's changing faster than you can measure it? How do you predict the behavior of geological systems that are operating outside all known parameters? The International Space Station provides the clearest view of what's happening. From orbit, astronauts can see the planet's changing proportions more clearly. Earth looks noticeably rounder, like a balloon that's been slightly inflated. The familiar blue marble of their childhood has become something subtly alien. It's still beautiful. Commander Lisa Park reports during her daily communication with Mission Control. But it's not the same planet we left. You can see it in the way the continents fit together, in the patterns of the clouds. Everything's just slightly wrong. As week 1 draws to a close, Earth has expanded by over 6 kilometers in diameter, That's enough to completely disrupt every geological, atmospheric, and biological system on the planet. Mountains have grown taller than they can support. Oceans have spread into new configurations. Weather patterns have collapsed. Animal migration routes have become meaningless. Human civilization's infrastructure has begun to crumble. And this is just the beginning. Because Earth isn't going to stop expanding. It's going to keep growing, 1 centimeter per second, day after day, week after week, until the blue marble we call home becomes something unrecognizable. The stable, predictable world that nurtured human civilization for thousands of years has become unstable and unpredictable. And everyone left alive is starting to realize that there's no going back. 30 days in, and I need you to prepare yourself for what I'm about to describe, because this is where our thought experiment becomes truly apocalyptic. Earth has swollen by 26 kilometers in diameter. To put that in perspective, that's enough to fit the entire width of Manhattan, between where the surface used to be and where it is now. But the size change is just the beginning of the horror show. The atmosphere, that precious envelope of air that makes life possible, has been stretched across this expanding sphere like plastic wrap being pulled over a balloon that's too big for it. And just like that plastic wrap, our atmosphere has become dangerously thin. At sea level, air pressure now equals what mountain climbers experience. At 4,000 meters above sea level, that's higher than most peaks in the continental United States. Every breath requires effort. Your lungs have to work harder to extract the oxygen they need from air that's become tenuous and insufficient. Sarah Martinez, a marathon runner from Denver, knows what thin air feels like. She's trained at altitude for years, but when she steps outside her apartment on day 30, she's hit with altitude sickness at sea level. It's like trying to breathe through a straw, she gasps, leaning against a wall for support. But there's nowhere to go down to get thicker air. Commercial aviation ceased weeks ago, not because of regulations or safety concerns, but because there simply isn't enough air density for aircraft wings to generate lift. Jets designed to cruise at 30,000 feet can't get off the ground in atmosphere that's been stretched too thin to support them. Captain Rebecca Chen, a pilot with 30 years of experience flying everything from single-engine Cessnas to jumbo jets, makes one final attempt to get her Boeing 737 airborne from Denver International Airport. The engines spool up to full power. The aircraft thunders down the runway, but no matter how fast she goes, there isn't enough air flowing over the wings to achieve takeoff speed. "It's not mechanical failure," she radios to the control tower as she brings the aircraft to a stop. "The air just isn't there anymore. It's like trying to fly on Mars." The stratosphere, that crucial layer of atmosphere that contains our ozone protection, has effectively disappeared into space. What ozone remains is so diluted that it provides virtually no protection against the sun's ultraviolet radiation. Stepping outside without protection means instant sunburn and long-term cancer risk that makes a day at the beach look like a gentle spa treatment. Hospital emergency rooms report an epidemic of radiation burns. People who spend just minutes outdoors develop blistering sunburns that would normally require hours of exposure. Children playing in their backyards for 10 minutes emerge looking like they've spent a day in the desert without sunscreen. Dr. Amanda Rivera, an emergency room physician in Phoenix, sees cases that defy medical explanation. "I've got patients with third-degree burns from walking to their mailbox," she tells a colleague during a rare, quiet moment. "The UV index is off the charts. We're measuring radiation levels that should only exist at high altitude, but we're at sea level." But the atmospheric thinning creates another problem that's even more immediate. Temperature regulation has completely broken down. Without sufficient atmosphere to distribute heat around the globe, temperature swings become brutal and immediate. The day side of Earth, directly facing the sun, reaches 50 degrees Celsius, hot enough to kill most vegetation and make human survival impossible without air conditioning. Meanwhile, areas in shadow plummet to -40 degrees Celsius. The gentle temperature gradients that create weather patterns and make most of Earth's surface habitable have been replaced by extremes that would be deadly on any other planet. In Phoenix, the temperature at noon reaches 52 degrees Celsius. The asphalt becomes soft enough to leave footprints. Car tires begin to deform from the heat. Metal playground equipment becomes too hot to touch without protective gear. The city that was once a thriving desert metropolis becomes literally uninhabitable during daylight hours. Meanwhile, Seattle experiences its first sub-zero temperatures in July, not just below freezing but -30 degrees Celsius, as the thin atmosphere fails to retain any heat from the distant sun. The coffee shops and outdoor markets that defined the city's culture shut down as residents huddle indoors, burning furniture to stay warm in a summer that has become colder than the worst winter in recorded history. Without the protective blanket of a dense atmosphere, space radiation that was once safely filtered out now reaches the surface. Cosmic rays, high-energy particles from deep space, bombard the planet directly. The Van Allen radiation belts, those magnetic fields that normally deflect dangerous radiation, become ineffective as the atmosphere they're designed to protect essentially evaporates. Geiger counters worldwide click frantically as background radiation levels soar. Areas that were perfectly safe yesterday become hazardous to human health today, not from nuclear accidents or weapons, but from the cosmos itself, no longer held at bay by an atmosphere thick enough to provide protection. But if the atmospheric crisis seems catastrophic, what's happening to the oceans is even worse. Earth's water, spread across vast new basins created by the expanding seafloor, has dropped by almost a kilometre in depth. A kilometre! That's 3,000 feet of ocean that has essentially vanished, not because the water is gone, but because it now has so much more space to spread out in. The Mariana Trench, once the deepest part of Earth's oceans at 11 kilometres below sea level, now measures only 10 kilometres deep. But it's not just the deep ocean that's affected. Continental shelves that have been underwater for millions of years stand exposed like ancient monuments to a world that no longer exists. The Bering Sea, that shallow body of water between Alaska and Russia, has dropped so dramatically that a land bridge emerges between the continents. For the first time in 15,000 years, you could theoretically walk from Asia to North America, if of course you could survive the radiation, temperature extremes and atmospheric conditions that would kill you long before you completed the journey. Marine life faces complete extinction. Deep-sea creatures, evolved over millions of years to survive under crushing pressure, literally explode as the pressure above them drops by thousands of pounds per square inch. Giant squid, those mysterious denizens of the deep ocean, surface in pieces as their bodies, perfectly adapted for high-pressure environments, fail catastrophically in the reduced depths. Dr. Maureen Dubois, an oceanographer studying from a research vessel in what used to be the deep Atlantic, watches her instruments register impossible readings. "We're seeing whale falls everywhere," she reports via satellite phone. Not just old carcasses, but fresh ones. Entire whale populations dying simultaneously as the pressure changes destroy their internal organs. Coastal ecosystems collapse entirely. Coral reefs, those vibrant underwater cities that took millions of years to build, find themselves exposed to air as sea levels drop. The Great Barrier Reef, visible from space for its brilliant colors and vast extent, becomes a white bleached graveyard stretching across what is now dry land. Tidal pools, those delicate ecosystems that exist in the narrow zone between high and low tide, disappear entirely as the ocean retreats beyond their reach. Creatures that have never known life outside of salt water die by the billions as their habitat simply evaporates. But it's what happens to large land animals that might be the most heartbreaking aspect of month one. If Earth is gaining mass as it expands, gravity has increased by 2%. That might sound minimal, But for creatures whose bodies are already pushing the limits of what Earth's gravity can support, it's a death sentence. Elephants, those magnificent giants that have roamed Africa and Asia for millions of years, can no longer support their own weight. In Kruger National Park, rangers find entire herds collapsed, their massive hearts unable to pump blood against the increased gravitational pull. These creatures, perfectly adapted for the old Earth, become impossible on the new one. Dr. James Kawira, a wildlife biologist in Kenya, documents the collapse of megafauna across the continent. It's not disease, it's not poaching, it's physics, he explains in a voice heavy with grief. Their circulatory systems can't handle the increased gravity. A 2% increase might not sound like much, but for an animal that weighs 6 tons, that's an additional 120 kilograms they have to carry. Their hearts just can't do it. Giraffes, those impossible creatures with necks that already challenge the limits of cardiovascular engineering, face an even more immediate crisis. Their hearts, evolved to pump blood 4 meters up to their brains against normal gravity, can't overcome the increased force. Giraffe populations collapse within days as their blood pressure regulation systems fail catastrophically. The great whales fare no better. Blue whales, the largest animals ever to exist on Earth, find that even the ocean's buoyancy can't compensate for the increased gravitational pull. Their massive hearts, designed to pump blood through bodies the length of passenger jets, begin to fail under stress they were never evolved to handle. Trees, those ancient pillars of terrestrial ecosystems, begin to topple worldwide. The California redwoods, those 1,000-year-old giants that have survived ice ages and droughts, fall like dominoes as their weight exceeds what their root systems can anchor against the stronger pull of gravity. In Yosemite National Park, the famous giant sequoias that have stood since before the Roman Empire crash to the ground with sounds like thunder. Each falling tree takes centuries of growth with it, creating clearings where ancient forests once stood. The ecosystem that developed over millennia in the shelter of these giants disappears in weeks. But perhaps the most devastating effect is what happens to human survivors. Not just the physical challenges of breathing thin air and avoiding radiation, but the psychological trauma of watching their world become alien. Cities empty, as buildings become uninhabitable death traps. New York's skyline, once a symbol of human achievement reaching toward the sky, becomes a graveyard of structural failures. Skyscrapers designed to sway in the wind can't accommodate foundations that spread apart as the ground expands beneath them. The Brooklyn Bridge, that iconic span that has connected Manhattan and Brooklyn for over a century, develops stress fractures as its massive stone towers spread slightly further apart. The carefully calculated tension in its cables, engineered to support specific loads at specific distances, becomes dangerously unbalanced. Emergency services collapse entirely. Ambulances can't navigate roads that crack and separate daily. Fire departments can't respond to calls when their trucks can't get through streets that change configuration overnight. Police find themselves unable to maintain order in a world where the very concept of fixed locations has become meaningless. Dr. Elizabeth Harper, a sociologist studying the collapse of urban civilization, documents the breakdown from her research bunker in underground Boston. "We're watching the end of cities as a viable form of human organization," she records in her daily log. "When the ground becomes unreliable, when buildings become uninhabitable, when infrastructure fails daily, you can't maintain the dense populations that define urban life. Hospitals evacuate patients to underground facilities as surface buildings become too dangerous to occupy. Surgery becomes nearly impossible as operating rooms experience daily structural changes that contaminate sterile environments. Medical equipment calibrated for specific gravitational conditions fails as the fundamental constants of physics change. The few aircraft still capable of limited flight report landscapes that look increasingly alien from above. Coastlines have moved inland by hundreds of kilometers. Mountain ranges have grown taller and steeper. Rivers flow in new directions or have disappeared entirely. The familiar geography that has defined human civilization for thousands of years has become unrecognizable. Agriculture, the foundation of human civilization, becomes impossible. Crops that were planted in soil of specific composition find themselves in ground that has stretched and changed its chemical makeup. Root systems that evolved for particular soil densities fail as the earth around them expands. The growing season that feeds billions becomes unpredictable as weather patterns collapse and soil composition changes daily. Livestock face the same gravitational challenges as wild animals. Cattle, sheep, pigs, domesticated animals whose breeding has optimized them for maximum size and productivity, become too heavy for their own skeletal systems to support. Farms worldwide report mass die-offs as animals that were thriving weeks earlier collapse under their own weight. Supply chains that took decades to optimize break down entirely. Ships can't navigate harbors that change depth daily. Trucks can't use roads that crack and separate. Rail transport becomes impossible as tracks warp and spread. The global economy that connected every corner of the world grinds to a halt as the physical infrastructure that supports trade becomes unreliable. By the end of month 1, human civilization exists only in underground bunkers and specially reinforced shelters. The surface world that nurtured human development for thousands of years has become a hostile environment where exposure to the elements means certain death. The International Space Station provides the only safe vantage point to observe what Earth has become. From orbit, astronauts see a planet that's recognizably round but eerily different from the world they left. The blue marble has become a larger, paler sphere where the familiar patterns of continents and oceans have stretched into alien configurations. We're watching the death of a planet. Commander Lisa Park radios to mission. Control in one of her final transmissions. Not explosion, not collision, just expansion into something that can't support the life it once nurtured. Earth is still here, but it's not Earth anymore. And the expansion continues, relentless and unstoppable, 1 centimeter per second, transforming the cradle of human civilization into a cosmic graveyard, where the only remaining question is how long any pockets of life can survive in a world that has fundamentally betrayed the basic requirements for existence. Now, I want you to step back with me from the immediate horror of what we've been describing and look at the truly cosmic implications of Earth's expansion. Because as devastating as the first month is, it's just the opening act of a transformation that will reshape our entire corner of the universe. Project this expansion forward, and Earth's destiny becomes something that transcends catastrophe and enters the realm of cosmic horror. At 1 centimeter per second, we double in size every 142 years. Think about that timeline for a moment. Within a single millennium, a time span that covers the entire history of medieval Europe to the present day, Earth surpasses Jupiter in size. But long before we reach that unimaginable scale, fundamental transitions occur that make everything we've discussed so far seem almost quaint by comparison. The dance of celestial mechanics that has kept our solar system stable for 4.5 billion years gets completely rewritten by a planet that refuses to stay the same size. Let's start with our oldest companion, the Moon. For 4.5 billion years, the Moon has been locked in a gravitational waltz with Earth, orbiting at an average distance of 384,000 kilometers. This isn't just some random distance, it's the precise balance point where Earth's gravity pulling the Moon inward equals the Moon's orbital velocity carrying it forward. But when Earth reaches twice its current size, something that happens in less than 3 centuries at our expansion rate, that delicate balance gets catastrophically disrupted. The Moon finds itself in a universe where the fundamental rules have changed, where the gravitational dance it has performed for billions of years suddenly requires new steps. If Earth is gaining mass proportionally as it expands, our strengthening gravity starts reeling the moon in like a fish on a cosmic fishing line. The moon's orbit begins to decay, slowly at first, then with increasing speed as it falls into the gravitational well of a planet that has become far more massive than the one it originally partnered with. Dr. Catherine Morrison, an astronomer who has spent her career studying orbital mechanics, runs the calculations on her computer and stares at results that should be impossible. The moon's orbital period is decreasing, she explains to her research team via encrypted communication from their underground facility. What used to be a 29-day cycle is now 28.7 days and dropping. The moon is spiraling inward, and the process is accelerating. Night by night, Earth's companion grows larger in the sky. What was once a distant silver disk becomes an enormous presence dominating the darkness. Tides, already disrupted by Earth's changing size and gravitational field, become tsunamis that reshape coastlines daily. The gentle ebb and flow that carved our shores for millions of years becomes a violent hydraulic hammer that pounds the continents. But it's not just the tides. The moon's increasing proximity destabilizes Earth's rotation entirely. Our planet, which has maintained a steady 24-hour day for billions of years, begins to wobble like a spinning top that's losing momentum. The axial stability that gave us predictable seasons disappears as gravitational forces pull our world in directions it was never designed to handle. The collision, when it finally comes, is beyond anything in human experience or imagination. Picture two celestial bodies, each with billions of years of geological history, smashing into each other at speeds measured in kilometers per second. Every mountain range that ever rose from Earth's surface, every ocean that ever teemed with life, every trace of human civilization that ever existed, gets incorporated into a molten ball of rock and metal spinning through space. The impact releases energy equivalent to trillions of nuclear weapons detonating simultaneously. The blue marble that nurtured human consciousness becomes a hellish sphere of lava, its surface temperature measured in thousands of degrees. For millions of years afterward, what was once Earth glows like a red dwarf star, radiating heat into space as it slowly cools from the cosmic collision that ended 4.5 billion years of planetary evolution. But in our mass gain scenario, an even more spectacular transformation awaits. If Earth keeps accumulating matter as it expands, eventually we reach a threshold that transforms our planet into something unrecognizable. A star. At roughly Jupiter's mass, EZA, about 300 times Earth's current weight, EZA-chi. Something incredible happens deep in our planet's core. The pressure from all that accumulated matter triggers electron degeneracy, pressure, and nuclear fusion begins. Earth ignites, literally becoming a small star. Let that concept sink in for a moment. Our blue marble, the pale blue dot that Carl Sagan wrote so beautifully about, transforms into a red dwarf star. The gentle yellow sun that has warmed our world for billions of years suddenly has company, a second star, born from the corpse of Earth itself, radiating nuclear fire into the solar system. Imagine our solar system with 2 stars instead of 1. The delicate gravitational choreography that keeps all the planets in their stable orbits gets completely disrupted. Venus, already a hellscape with surface temperatures hot enough to melt, Lead, experiences stellar radiation from 2 directions. The planet that some scientists once thought might harbor life becomes something even more extreme, a world caught between 2 stars, its surface bombarded by radiation that vaporizes rock. Mercury simply ceases to exist as a solid body. The innermost planet, already subjected to intense solar radiation, gets blasted by energy from Earth's stellar incarnation. Within years, maybe decades, Mercury's surface boils away into space, leaving nothing but a glowing cloud of metallic vapor where a planet used to orbit. Mars might survive, barely, but its thin atmosphere gets stripped away entirely by the stellar wind from 2 stars instead of 1. The red planet that captured human imagination for centuries becomes a barren, airless rock, its polar ice caps sublimated into space by radiation pressure that overwhelms its weak gravitational field. The asteroid belt, that collection of rocky debris between Mars and Jupiter, gets scattered like cosmic billiards as gravitational relationships throughout the inner solar system collapse. Chunks of rock that have orbited peacefully for billions of years suddenly find themselves on chaotic trajectories, some falling into the new star that used to be Earth, others flung out toward the outer planets or ejected from the solar system entirely. Even Jupiter, that massive guardian of the outer solar system, finds its orbit altered by the presence of a second star. The gas giant that has protected inner planets from asteroid impacts for eons begins a slow migration outward, as the combined gravitational influence of two stars changes the fundamental architecture of our cosmic neighborhood. And Earth, the living, breathing world that nurtured billions of years of evolution, becomes something so fundamentally different that calling it Earth seems almost insulting to the memory of what it once was. Every forest that ever grew, every ocean that ever sparkled in sunlight, every creature that ever lived gets transformed into the nuclear fires of stellar fusion. The carbon atoms that once made up human bodies burn in stellar cores, creating heavier elements that get blown into space by stellar winds. The oxygen that once filled lungs becomes part of the fusion process that powers a red dwarf star. The very atoms that composed every living thing get recycled through nuclear processes that operate on energy scales beyond human comprehension. Now, let's consider the alternative scenario, AM, expansion without mass gain. This path leads to a different but equally alien fate. As Earth expands while maintaining the same mass, our density drops dramatically. We become less like a solid planet and more like a cosmic soap bubble, a gossamer sphere with gravity too weak to hold onto the basic components that make a world habitable. The atmosphere, already stretched thin after a month of expansion, continues to hemorrhage into space. Without sufficient gravitational pull to maintain atmospheric pressure, Earth's protective envelope simply drifts away. First the outer layers, then progressively denser regions, until even the air at what used to be sea level escapes into the void. Oceans face the same fate. Water, no longer held down by adequate gravity, begins to sublime directly from liquid to vapor, and then to escape into space. The hydrological cycle that has shaped Earth's climate for billions of years breaks down as water molecules gain enough energy to achieve escape velocity and leave the planet entirely. Within centuries, Earth becomes a hollow shell, a rocky balloon drifting through space with gravity too weak to maintain any of the characteristics that define a living world. No atmosphere, no water, no magnetic field, no geological activity, AETI, just a giant sphere of rock expanding slowly into the cosmic dark. But even this fate isn't the end of the transformation. As Earth continues to expand, our internal structure changes dramatically. The molten core that generates our magnetic field, protecting us from solar wind and cosmic radiation, cools and solidifies as the planet's internal pressure drops. The magnetic field that has shielded life for billions of years simply turns off. Plate tectonics, the engine that has driven continental drift and recycled Earth's surface for eons, grinds to a halt. Without sufficient internal pressure to maintain molten rock in the mantle, the geological processes that create mountains, ocean basins, and continents cease to function. Earth becomes geologically dead, a static sphere where nothing changes except the slow expansion that continues to stretch its lifeless surface. The Van Allen radiation belts, those magnetic fields that deflect deadly cosmic radiation, disappear entirely. What's left of Earth's surface gets bombarded directly by high-energy particles from space. Any complex molecules that might have survived the atmospheric loss get broken down by radiation that no longer has any barrier to stop it. In either scenario, AI, stellar ignition, or hollow expansion, MCO, the end result is the complete erasure of every trace of the world we know. Every human achievement, every work of art, every story ever told, every love letter ever written, every child's drawing ever proudly displayed on a refrigerator, Earth 3, all of it disappears into cosmic transformation that renders the very concept of Earth meaningless. The stable, nurturing world that allowed chemistry to become biology, that let biology become consciousness, that enabled consciousness to contemplate its own existence, becomes something so alien that future space travelers, if any survive from other worlds, would never guess that this stellar furnace or hollow shell once harbored life. But here's what makes this thought experiment so profound. It forces us to confront the incredible precision required for Earth to support life at all. Our planet isn't just a big rock that happened to work out okay. It's a precisely calibrated system where every parameter has to be exactly right for the whole thing to function. Change Earth's size by even a small amount over geological time, and everything falls apart. Make us too big, and we become a gas giant that can't support solid surfaces. Make us too small, and we can't hold on to our atmosphere or maintain geological activity. The size we are, now, 12,756 kilometers in diameter, isn't arbitrary. It's the perfect size for a world that can support liquid water, geological recycling, atmospheric retention, and magnetic field generation. Our expansion nightmare reveals Earth not as a simple ball of rock, but as an impossibly complex machine where countless systems work together in perfect harmony. Atmosphere, oceans, geological activity, magnetic fields, orbital mechanics, every component depends on every other component, and all of them depend on Earth being exactly the size it is. The next time you look up at the moon, remember that its distance from Earth isn't random. It's precisely calibrated to create tides strong enough to mix the oceans, but not so strong as to scour the continents bare. The next time you take a breath, remember that our atmospheric pressure isn't accidental. It's exactly right to allow liquid water to exist at the surface while protecting us from radiation and temperature extremes. This cosmic horror story of expansion helps us understand something beautiful. The mundane, unchanging Earth beneath our feet is actually the most finely tuned machine in the known universe, and it's been running perfectly, without maintenance, for longer than we can possibly imagine. So here we are, at the end of our journey through this cosmic nightmare. We've watched civilization crumble in days, seen ecosystems collapse in weeks, witnessed the death of oceans and sky in a month, and projected forward to cosmic transformations that erase every trace of the world we know. But now I want you to step back from this horror show and appreciate something truly remarkable, the razor's edge we actually balance on. Because here's the thing that this thought experiment reveals in stark, terrifying detail. Earth's size stability over billions of years isn't just luck. It's not some cosmic accident that happened to work out in our favor. It's the foundation of everything. Literally everything. Think about what we've learned by imagining what happens when Earth grows by just 1 centimeter per second. Within hours, GPS systems fail and buildings crack. Within days, tectonic plates tear apart and volcanoes erupt globally. Within weeks, weather patterns collapse and animals die from gravitational stress. Within a month, the atmosphere becomes unbreathable and oceans drain into expanded basins. 1 centimeter per second, that's about the width of your fingernail. That tiny, insignificant measurement, applied consistently to our planet's growth rate, destroys everything in a matter of weeks. But let's dig deeper into why this happens, because the answer reveals something profound about the world we live on. Change our diameter by even 1% over geological time, not the rapid expansion we've been imagining, but slow change over millions of years, and plate tectonics fails entirely. You see, plate tectonics isn't just about continents drifting around. It's the planet's recycling system, the mechanism that moves carbon between the atmosphere and Earth's interior. Without plate tectonics, we have no carbon cycle. Without a carbon cycle, we have no climate regulation. The delicate balance that keeps Earth's temperature in the narrow range where liquid water can exist gets completely disrupted. Dr. Sarah Kim, a geochemist who has spent her career studying the carbon cycle, explains it this way. Earth's climate stability depends on plate tectonics moving carbon-rich rocks from the seafloor into the mantle, where heat and pressure break them down and release carbon dioxide through volcanic eruptions. Change the planet's size, and you change the internal pressure that drives this process. No pressure, no recycling. No recycling, no climate control. But it goes even deeper than that. The magnetic field that protects us from deadly solar wind and cosmic radiation, that's generated by precise convection patterns in our liquid iron core. Those convection patterns depend on exact pressure from exact mass at exact size. Change any of those parameters, and the magnetic dynamo that has shielded life for billions of years simply shuts down. Imagine Earth without a magnetic field. Solar wind, any day, that stream of charged particles constantly flowing from the sun, hits our atmosphere directly. Over geological time, it strips away our protective envelope of air, molecule by molecule, until we end up like Mars, a cold, airless rock where any water that once existed has either frozen solid or escaped into space. The atmospheric pressure that allows liquid water to exist at our surface isn't arbitrary either. It's exactly calibrated to the triple point of water, psi, the narrow range of temperature and pressure, where H2O can exist as solid, liquid, and gas simultaneously. Too little pressure, and water boils away into space. Too much pressure, and we get a runaway greenhouse effect like Venus, where surface temperatures reach 460 degrees Celsius. Every earthquake that reshapes our landscape, every volcano that adds new land to our continents, every raindrop that nourishes our forests, all of it exists because Earth stopped growing 4.5 billion years ago and has remained precisely the same size ever since. But here's where it gets really mind-bending. Our expansion thought experiment reveals that Earth isn't just a big rock floating through space. It's more like a living organism, countless systems in perfect balance, each depending on all the others. Disturb one parameter, even slowly, and the whole system collapses faster than dominoes falling in sequence. Consider the hydrological cycle, HA, the movement of water between oceans, atmosphere, and land. This system depends on exactly the right amount of solar energy hitting exactly the right-sized planet, with exactly the right atmospheric pressure and exactly the right gravitational field. Change any of those variables, and the cycle breaks down. Too much solar energy, and all our water evaporates into space. Too little, and it all freezes solid. Wrong atmospheric pressure, and water can't exist as a liquid. Wrong gravitational field, and clouds can't form properly, or rain can't fall in the right patterns. The ocean currents that distribute heat around our planet and make most of Earth's surface habitable, they depend on precise differences in water density caused by temperature and salinity gradients. Change the planet's size, and you change the gravitational forces that drive these currents. Change the atmospheric pressure, and you change the evaporation rates that maintain salinity. Change the magnetic field, and you alter the cosmic radiation that affects cloud formation. Everything connects to everything else in a web of dependencies so complex that we're still discovering new connections after centuries of scientific study. And all of it, every single component of this planetary life support system, APC, depends on Earth being exactly the size it is. The tidal forces that our moon creates aren't just pretty to watch. They're essential for mixing the oceans, preventing stagnation, and possibly even for kick-starting life itself by creating tidal pools where complex chemistry could develop. Change Earth's size, and you change the gravitational relationship with the moon. Change that relationship, and tides either become too weak to maintain ocean circulation or too strong to allow life near shorelines. Our planet's rotation rate, which gives us 24-hour days, isn't random either. It's fast enough to create weather patterns that distribute heat and moisture around the globe, but not so fast that atmospheric circulation becomes chaotic. Change Earth's size significantly, and you change its moment of inertia, which changes its rotation rate, which changes weather patterns, which changes everything. The length of our year, the time it takes Earth to orbit the Sun, depends on our exact distance from our star and our exact orbital velocity. That orbital velocity depends on our exact mass, which depends on our exact size. Change any of these parameters, and Earth either spirals into the Sun or drifts away into the cold outer solar system. Even the chemical composition of our atmosphere represents an impossibly delicate balance. 21% oxygen is exactly right to support complex life without causing everything to spontaneously combust. Too little oxygen, and large animals can't extract enough energy from their environment. Too much, and the slightest spark turns the entire biosphere into a fireball. That oxygen percentage is maintained by photosynthesis from plants and plankton, which depends on the right amount of sunlight reaching the surface, which depends on exactly the right atmospheric composition and pressure, which depends on exactly the right gravitational field, which depends on exactly the right planetary size. Dr. Lisa Patel, an astrobiologist who studies the conditions necessary for life, puts it this way: when we look for potentially habitable planets around other stars, we're not just looking for rocky worlds in the Goldilocks zone where liquid water could exist. We're looking for planets that are exactly the right size, with exactly the right mass, orbiting exactly the right type of star at exactly the right distance, with exactly the right rotation rate and exactly the right magnetic field strength. The number of variables that have to be precisely calibrated is staggering. And here's what really gets me. All of these systems we have been running smoothly for billions of years. Think about that timeline. Billion, with a bay. Our planet has maintained stable conditions for life, not just for human history, not just for the history of complex life, but for most of the time since the solar system formed. Through ice ages and warm periods, through asteroid impacts and volcanic catastrophes, through the rise and fall of countless species, Earth has maintained the basic parameters that make life possible. The size that allows plate tectonics to function, the mass that generates the right gravitational field, the distance from the Sun that keeps water liquid, the magnetic field that protects us from radiation. Our mundane, unchanging Earth, the world we take for granted every single day, suddenly seems like the most precisely tuned machine in the universe. And you know what? It is. The next time you're outside, I want you to try an experiment. Feel the solid ground beneath your feet, ground that has been exactly the same distance from the center of the planet for your entire life, and for countless generations before you. Notice how the air fills your lungs effortlessly at exactly the right pressure to keep you alive. Watch how clouds drift across a sky that's been exactly the same distance above your head since before your species existed. Listen to the birds that navigate by magnetic fields that have been stable for millions of years. Watch the tides that rise and fall in patterns that have been consistent since before complex life existed. Feel the breeze that's part of atmospheric circulation patterns driven by a planet that rotates at exactly the right speed to make weather possible. All of this stability, all of this perfect balance, exists because our planet's size was locked in place billions of years ago by the fundamental laws of physics. The cosmic debris that coalesced to form Earth added up to exactly the right amount of mass to create exactly the right gravitational field to maintain exactly the right atmospheric pressure to support exactly the right chemical reactions to enable life to evolve and consciousness to emerge. Change that one simple parameter, add just 1 centimeter per second to Earth's growth rate, and everything we know and love disappears into cosmic horror. But Earth isn't growing. It's been the same size for longer than you can possibly imagine, and as long as the laws of physics continue to work the way they always have, it will stay that size for billions of years to come. Our stable, predictable, wonderfully boring planet will keep spinning through space at exactly the right distance from the sun, with exactly the right gravity to hold our atmosphere, and exactly the right size to keep all the geological systems running that make our world a place where life can thrive. That fingernail width we started with, that insignificant little centimeter that seemed so harmless, it turns out to be the perfect measurement for understanding just how precious our stable Earth really is. In a universe where planets can be gas giants or airless rocks, where they can be frozen solid or molten hellscapes, where they can have crushing gravity or no atmosphere at all, we live on the one world that got everything exactly right. And that's not luck. That's not coincidence. That's the fundamental requirement for existence itself. Earth isn't just our home. It's a cosmic miracle of precision engineering that has been running flawlessly since before life began, and will continue running long after our species is gone. So the next time someone asks you what makes Earth special, you can tell them it's not just that we have liquid water or a breathable atmosphere or a magnetic field. It's that we have exactly the right amount of everything, balanced with exactly the right precision, maintained by exactly the right planetary size, for billions of years without fail. In a cosmos full of worlds that got it wrong, we live on the one, a planet that got it exactly right, and now you understand just how remarkable that really is.